Hello friends, I'm back again. Last time we concluded our number base class and I told you that we are done, but we are not done. We are done because we have taken them step by step, the subtopics that it contains, and we have exhausted it. But this time around, I promised you in the last class that we are going to solve additional questions aside from the little examples I gave while I was teaching. These additional questions, we'll pick some of them from Waec, we pick some of them from JAMB, because these are the two major exams that we experience or we are going to take after our SS3 class. So I've come in this video to expose you to the way Waec and JAMB prepare questions in number base, not just like what you see in your textbook. And I hope you're going to enjoy the class. If this is your first time of joining our video, don't forget to subscribe, like, and make your comments. You can ask your questions in the comment section, and I promise you in the next video we'll try to solve your questions. Come with me and join us in the class. This is a Waec question that says, if 2n4 base 7 equals 15n base 9, find the value of n. Now, when you see this kind of question where a certain number in a certain base is equated to another number in a certain base, usually different base, the same step we are going to take every time is to convert both sides of this equation to base 10. No matter how the question is, just try to follow the step of conversion to convert both sides, both the left side and the right side, to base 10. And if you look at this, you realize that this 2 and 4 means there is a number that is between 2 and 4 here, but is represented with n. There is a number after 5 that is represented with n. And that is what the question wants us to find. What is that number? So like I said, when you have this nature of question, all you need to do is to first of all convert both to base 10 and simplify, probably collect like names, and you will realize it will lead you to the answer. So how do we convert to base 10? Remember, what we do is to assign place values to both of them. So you have 0 here, you have 1 here, you have 2 here. The same here, you have 0, 1, 2. So this one is in base 7. To convert to base 10, we take the first digit, 2 times the base 7 raised to power the place value assigned to it 2, plus the next digit is n times the base 7 raised to power the place value given to it 1, plus the next digit is 4 times the base, which is 7 raised to power the place value given to it 0. And we are done with the left hand side of the equation. Then going to the right hand side, it is equal to the first digit there is 1 times the base. The base of this right hand side is 9. So you use 9 here, raised to power the place value, which is 2. Plus the second digit here is 5 times the base, which is 9, raised to power the place value 1. And then finally we have n times base 9 raised to power the place value 0. So we have been able to convert these numbers in base 7 and 9 respectively to base 10. So we simplify, we say this becomes 2 times 7 raised to power 2 is 49, plus the next one is n times 7 raised to power 1 is still 7, plus the next is 4 times 7 raised to power 0 is 1. And that is equal to 1 times 9 raised to power 2 is 81, plus 5 times 9 raised to power 1 is 9, plus n times 9 raised to the power 0 is 1. And then we simplify further. 2 times 49 will give us 98. Plus 7 times n will give us 7n. Plus 4 times 1 will give us 4. Equals 81 times 1 will still be 81. Plus 5 times 9 will give us 45. Plus n times 1 will give us n. So we collect like terms. In collecting like terms, those ones that are carrying n, that contains n, will be taken to the left hand side because we are looking for n. And then the constants, those ones that don't have n, will be taken to the right hand side. So you see 7n is already at the left, and then the next one that contains n is this n at the right. So we'll move it, and once a number crosses the sign of equality, the sign changes. It is plus here and it crosses to minus n. Then equal to 81 is already at the right hand side, 45 is also at the right hand side. Then we move this other 2 to the right hand side. So if I move 4 to the right hand side, it becomes minus 4 because it is plus and it has crossed the equality sign. 98 also is positive here. When a number doesn't have a sign before it, of course, is positive. So when it crosses the sign of equality, it will be minus 98. And then we simplify further. 7n minus n, we have 6n equals, and when you add 81 to 45 minus 4 minus 98, you will get 24. If you punch your calculator very well. Then since we have simplified it to this point, to make n the subject of the formula, we divide both sides by 6, by the coefficient of n, which is 6. So that this 6, we cancel this 6. And it therefore means that n is equal to 24 over 6, and that is 4. So n is 4, and we'll be able to solve this question. This is a Waec question, and we've solved that. So what it means is that this is 244 base 7 is equal to 154 base 9. Another question from Waec 2008, number 1 question that year. It says if all numbers in the equation y all over 1 plus 101 equals 11 over 10010 are in base 2, solve for y. Now you have y in 2 places, we are looking for y. It's just the same thing. All you have to know is that in multiplying base 2, you have to consider that the highest digit that can exist in whatever we are solving here is 1. So we have only zeros and 1. We cannot have 2 or more than 2. So let us cross multiply. Of course, when you have this kind of equation, what you do is to cross multiply, collect like terms, make the unknown the subject of the formula by any possible means. So when we have these fractions, the first step is to cross multiply so that we'll clear the fraction. That is the first step, to clear the fraction. So when we cross multiply, this one will multiply this one across, and this will multiply this across. So if y multiplies this across, we are going to have 10010 y. And if 11 sorry, this is not 11, this is 1 because it's in base 2, multiplies this one across, equal to 1 multiplying y plus 101. And we simplify further, we have 10010 y equals 1 multiply y, you have 1 y. And 1 will multiply this one, plus 1 will also multiply 101. And then let us do that as a rough work. Of course, that step is not possible, is not necessary, but let us see how we will get it. 101 multiplied by 1 we have learned this thing before. If 1 multiply everything here, you have 101. This one multiply again, we have 101 in that step, because say 1 times 1 times 0 0, 1 times 1 1 times 1 1 times 0 0, 1 times 1. Then we add. When we add, 1 here will come down, 1 here will come down, 1 plus 0 1, and then 1. So these two will give us 1 1 1 1. So what we are going to have here is 10010 y is equal to 11y plus 1111. You can see that, and then you see that this contains y, this contains y, but this doesn't contain y. So we are going to collect like terms, so that we'll have 10010y minus 11y, because when it crosses the sign of equality, it becomes negative, equals 1111. Then we are going to factor y out because they are exist in both numbers. So we'll have 10010 minus 11, then multiply by y, because this y, if you open this bracket, will still return in this form, equals 1111. Now go back to our rough work. We determine this minus this the same way we've learned subtraction of number base. That is what we apply here. So we have 10010, subtract 11 from it. So we have this 0 minus 1 cannot go. You borrow 1 from the next number and call it 2 because it's in base 2. 2 minus 1 is 1. 0 is remaining here because we have removed 1 from it. And then 0 minus 1 cannot go, and we borrow from the next one. Since the next one is 0, we check the next one. It's 0, we check the next one, 1. We borrow 1 from here. Remember, if we have borrowed here, remember 0 that is here now. We borrow 1, put it here, call it 2. And then borrow 1 again from that 2, put it here, call it 2. Then borrow 1 again from that 2, put it here. Remember, this was 0 because we've removed the 1 here. It becomes 2. 2 minus 1 will give us 1, and 1 is remaining here. After we've removed 1 from the 2, it is now 1. Then 1 is also remaining here, 1, and remember, it is here we raised that 1 from, so this is 0. So we have 1 1 1 1. So 10010 minus 1 1 will give us 1 1 1 1 base y equals 1 1 1 1. And of course, you have to divide both sides by the coefficient of y in order to make y the subject of the formula. So we say divide both sides by 1 1 1 1, and that is, we have seen that this will cancel this and y will be equal to 1, because this as well will cancel this. And that is how we've been able to obtain the value of y from the equation given by Waec in the year 2008, number 1. Remember, we can as well solve this question by converting 1 to base 10, convert 10010 to base 10, convert 101 to base 10, and put it in this equation and solve, get your y, and then that y will be converted back to base 2. You can do that. It's still going to give you the same answer after you convert, but you know it is a long process to begin to convert them individually. So let's look at another question. Another question from Waec 2014, number 2 says, if 124 base n is equal to 232 base 5, find n. Okay, here the same thing we did in the first question was solved. What we need to do is to convert both sides to base 10, and you see ourselves solving for n. So to convert this one, the left hand side, to base 10, remember you assign 0 1 2. The first digit here is 1, multiplied by the base is n raised to power the place value 2. The next digit here is 2, multiplied by the base n raised to power of the place value 1. The next digit is 4, multiplied by the base n raised to power of the place value 0. And we are done with the left hand side. Equal to the right hand side, we have 0 1 2 as well. The first digit is 2, multiplied by the base 5 raised to power of the place value is 2. The next digit plus 3, multiplied by the base 5 raised to power of the place value 1. And then finally, the next digit is 2, multiplied by the base 5 raised to power of the place value 0. And we are done with expanding. So if we simplify further, this is n squared times 1, you have n squared. This is 2n raised to power 1 is n times 2, you have 2n. Plus this is 4 times n raised to power 0 is 1. Equals 2 times 5 raised to the power 2 is 25, plus 3 times 5 raised to the power 1 is 5, plus 2 times 5 raised to the power 0 is 1. Simplify further, you have n squared plus 2n. 4 times 1 plus 4 times 1 is 4, equals 2 times 25 is 50, plus 3 times 5 is 15, plus 2 times 1 is 2. Then we have n squared plus 2n plus 4 equals, because these are all constants, if you add it, you have 50 plus 15 is 65, plus 2 is 67. If you look at this, you realize we are arriving at a quadratic equation. So you have n squared plus 2n plus 4, then minus 67. If this 67 should cross the sign of equality to be negative, equals 0. Because if you remove 67 here, 0 will remain. So this will give us n squared plus 2n. 4 minus 67 will give us minus 63 equals 0. Now from here, we can now solve quadratic equation using any method of our choice. I'm not going into details in quadratic equation. If you want to learn quadratic equation, you go and watch our video on quadratic equation. But now we're just going to apply it. If I use the method of factorization, where we look for two digits that if you add we give you 2n, and when you multiply we give you minus 63n squared, that is these two put together. So these two digits I can actually get from what we did under quadratic equation. These two digits will be plus 9n minus 7n, because if I subtract 7n from 9n, I'll get 2n. If I say 7n times 9n times minus 7n, I'm going to get minus 63. So that will work. So that is this. Then you pair them in twos. This and this, the factor, common factor they have is n. So if I factor out n from n squared, I'll have n. If I factor out n from 9n, I'll have 9 left. And we are done with this. Then you pair these two as well. If I factor, you realize that what is common is minus 7. If I remove minus 7 here, I have n. If I remove minus 7 from 63, that is divide minus 63 by minus 7, I will have 9. In factorization, you must ensure that what you have in the first bracket is the same as what you have in the second bracket. If it is not so, then you are not getting it right. Because when you do that, we are just going to pick one out of the two brackets and then pick the one outside the bracket to form the second bracket. N minus 7 equals 0. And then this implies that n plus 9 is equal to 0, or n minus 7 is equal to 0. So when you make n subject to the formula, you have to move 9 to the right hand side so that n is equal to minus 9, or you do the same here. N, when minus 7 crosses, it becomes plus 7. So these are the two possible values of n. But the base cannot be negative. The base cannot be negative. Therefore, n is equal to 7. So that is it. That is it for now. We are going to solve more questions in our next video, but enjoy this one, assimilate it for the meantime, so that when we get to solve other questions, you will appreciate number base the more. Thanks for being part of the class. I hope you enjoyed it. See you in the next class.